I am P. Gomati, Assistant Professor, Department of Mathematics. So in this lecture, we are going to see about Gauss Divergence Theorem. So first of all, let me define what is a Gauss Divergence Theorem. So if f vector is a vector point function which is finite and differentiable in a region capital R bounded by a closed surface S, then the surface integral of the normal component of f vector taken over S is equal to the integral of divergence of f vector taken over V. That is, double integral over S f vector dot n cap ds is equal to triple integral over V del dot f vector into dV. Here double integral denotes the surface integral and triple integral denotes the volume integral. And n cap is the unit vector which is normal to the direction positive counterclockwise and which is drawn to the normal S. So based on the Gauss divergence theorem, we are going to solve a problem. So problem number 1, verify Gauss divergence theorem for f vector equal to 4xz I vector minus y square j vector plus yz k vector over the cube x equal to 0, x equal to 1, y equal to 0, y equal to 1, z equal to 0, z equal to 1. So we all of you know that by the definition of Gauss divergence theorem, double integral over S f vector dot n cap into ds equal to triple integral over V del dot f vector into dV. For proving the theorem Gauss divergence to be verification, we have to prove the left hand side and right hand side to be equal. So for this I am taking the right hand side. So for right hand side, let us first solve del dot f vector. So del dot f vector is nothing but our del is dou by dou x into I vector plus dou by dou y into j vector plus dou by dou z into k vector. Dot f vector is nothing but 4xz I vector minus y square j vector plus yz k vector. So when you take dot product, I dot I will be 1 and j dot j will be 1 and similarly k dot k will be also 1. So dou by dou x of 4xz plus dou by dou y of minus y square plus dou by dou z of yz will come. So which is equal to, so differentiating 4xz with respect to x, we get 4z because differentiation of x is 1. Similarly, when you differentiate minus y square with respect to y, you get minus 2y plus differentiating yz with respect to z, you get y. So when you add all those three terms, you get 4z minus y. So now let us substitute this del dot f in the right hand side portion. So triple integral del dot f is 4z minus y into our dv is dx, dy and dz. And the limits are given by 0 to 1, 0 to 1 and 0 to 1. So when you integrate this with respect to x, you get 4zx minus yx between the limit 0 to 1. After that you integrate with respect to y and after that you integrate with respect to z. So when you substitute the limits as 0 to 1 for x, y and z, you get the answer to be 3 by 2. So 3 by 2 is our right hand side solution. Next let us solve for the left hand side solution. So what is our left hand side? So double integral over S f vector dot n cap into ds. Here the surface integral is divided into 6 portions, S1, S2, S3 and S4, S5, S6. So our n cap is nothing but for the upper portion you get plus I vector and for the lower portion you get minus I vector. Similarly j vector, minus j vector and k vector and minus k vector. Our ds is nothing but dy dz for I vector and minus I vector. Similarly dx dz for j and minus j and dx dy for k and minus k. So our phase equation is nothing but upper limit is given by x equal to 1 and lower limit is x equal to 0. Similarly y equal to 1, y equal to 0 and z equal to 1, z equal to 0. So first let us find for the surface 1, that is ABCD. So double integral over S1 f vector dot n cap ds is equal to double integral ABCD 4xz I vector minus y square j vector plus yz into k vector dot our n cap is I vector into dy dz. So when you take dot product for I vector alone, you get 4xz dy dz and y limit and z limit are same 0 to 1. After integrating and substituting x to be 1, you get 2. Similarly, you have to find for all the surfaces S1, S2, S3 up to S6. So when you find S2, the answer is 0 and for S3 our answer is minus 1 and for S4 you are getting 0 and S5 it is 1 by 2 and for S6 we are getting 0. So when you add all the 6 surfaces, that is 2 plus 0 plus minus 1 plus 0 plus 1 by 2 plus 0, we are getting the answer to be 3 by 2, which we obtain in the right hand side also. So from this we can easily say that double integral over C S f vector dot n cap ds is equal to triple integral over V del dot f vector into dV. Hence Gauss divergence theorem is verified. So from this we can conclude the portion as the Gauss divergence theorem is verified from the given equation, where the problem is given by f vector is equal to 4xz I vector minus y square j vector plus yz k vector. Hope you all understand. Thank you.